All right. So like I was saying before, solving a quadratic inequality is extremely similar to solving a quadratic equation. The only difference is, okay, instead of an equal sign, there's an inequality sign. Now, when you think about this, let's take a look at this inequality. What is this saying? What solutions does it want? Does it want to know when the quadratic is equal to 0 anymore? Not less than. When the equation, the quadratic, is greater than 0. So, now don't draw this. This is just an example. If I am looking at a graph, and this is a quadratic, so we're going to pretend that this quadratic looks like this. Where is this quadratic greater than 0? Let's say this is 2 and this is 5. Where is it greater than 0?
2 and 5.
On 2 and on 5?
Yes. Good. On it. Below.
Above. Right? If we want to know when it's greater than 0, it's all of the x values that make it above 0. Now what if we wanted to know where it was less than 0? Where would I shade then? Yeah, between the two numbers. So guess what? There's only two possibilities. Either, oh my God, shading outside of the two numbers or shading between the two numbers. Those are the only two possibilities we could end up with. And that'll make more sense in a second. I just wanted you to know what we're looking at, what we're visualizing here. So let's try it. We start off the exact same way that we start off an equation. How do we start? Yes, we try to factor it. Now before we start factoring, what do we look for? GCF, yes, a greatest common factor. Is there one here? What goes up top? 3. What goes in the bottom? And I ask, what two numbers multiply to be 3 but add to be -4? Yes, -3 and -1. And these are my factors, x minus 3, x minus 1. Are these my true factors? Yes, they are. How do I know? You don't have an A. What do I do next? Yes, you set them both, in this case, greater than 0. So I add 3 over, and I add 1 over. Now, the reason why in the beginning I showed you that graph.
I'll just write that down so fast. It looked down for like 2 seconds.
I'm sorry. The reason I showed you that graph is because look at what these inequalities are saying. Both of the inequalities say what? That x is greater than the number. Let's think about that on a graph. We're saying that the range of solutions is when x is bigger than 1 and also bigger than 3. That's like shading all of that. But remember, the original equation wanted to know when the equation was greater than 0. Are both of those shades greater than 0? No. So guess what? One of these inequality signs is wrong. One of them will always be wrong. We have to figure out which one's wrong. Does anyone know how we could do this? I'd be impressed if you did. We substitute values in. Yes. Now, I'll show you how the easiest way to do this. First, draw a number line. And put your two values on this number line. So we have 1 and 3. Now on this number line, are they going to be closed dots or open dots?
Open.
Why open?
They're not equal to.
Yeah, because they're not equal to. Now, remember I said there's only two possibilities, either shading outside or shading between, right? So because there are only two possibilities, we only need to plug in one number. What is the easiest number to plug in?
0.
0. 0 is the easiest because it'll make most things cancel out. Now, where is 0 on this number line?
Behind the 1.
In front of the 1, right? That's important to know. You had to figure out where is 0. And now we're going to plug 0 back in. This is our check. We're going to plug it back into the original. Plug 0 in for x. You will always plug in 0. Always, always, always. Because it's the easiest. So, what does this simplify down to? 0 squared minus 4 times 0 plus 3. What are you left with?
3.
Just the 3. And now you ask yourself, is this true? Is 0 less than 3?
Yes.
Yes. Check, it works.
Oh.
Meaning, on our number line, where we see the 0, we shade. Now, because I shaded outside, where else do I need to shade? On the other outside. Right? Because if I'm thinking about this on a graph, remember, either it's both outsides or it's the inside. So if I shade on one outside, I need to shade on the other outside. So looking at this graph, looking at this number line, which of the inequalities was wrong? No.
1.
Which one?
3.
1.
The 1.
I said 1, but you said no.
You said both of them, and I said no.
Wow.
It's the 1, right? Is x greater than 1? Did we want where x was greater than 1? Where did we shade compared to 1? Less than. So here, if I'm writing the solution in inequality notation, x is where from 1?
Greater.
From 1, where did we shade? Less than 1. Or x is where from 3? Where did we shade? Bigger than 3. This is our solution. Don't worry, I'm going to do at least 2 more examples.
Wait, what?
Take a look at all this. Do you have any questions before I do example 2? So the process is factor, find solutions, draw a number line, plug in 0. If 0 works, shade where 0 is. If 0 doesn't work, what do? Don't shade where 0 is.
Don't shade.
Okay, next one. Now on this one, I want us to change the inequality sign actually. I want you to make the inequality sign the other way. So, what do I do first? I'm going to start picking names here. What do I do first, Gennaro? First, what do I need though? Yes, I need to move everything over to one side. So how do I move everything over to one side, Avery? Take a look. Look, look, look. What do I need to do? Yes. One of the things I need to do is subtract 4 over, and the other thing is subtract x. So what do I end up with here, Grayson?
X squared, 7x, went up 5x, negative 14.
That's a plus.
And 6.
Good. That's what I end up with. Now what do I do next? Cheyenne. Yes. I look for a GCF. Is there one? No. So I immediately jump into X method.
1.
What goes up top? Alex.
6.
And what goes in the bottom? Hold up. David.
This is interesting. I like this one.
What goes in the bottom?
And I'm gonna get mine.
5.
Yes. Now, what do we ask ourselves here? Kayla just left. Catherine. Yeah, what can multiply to get and add to get? So, what two numbers, anybody, can multiply to get 6 but add to be 5?
2 and 3.
Yes. Now, are these my true factors, Lindy?
Yes,
Yes. How do I know, Lindy?
because there's no A value.
Yes. So, shh. What do I do next? Colby's not here. He's got the flu. Naya, what do I do next?
Yeah.
You get the number to the other side of that.
Yes.
That was not a real handshake.
So here, I'm going to subtract 2 over and subtract 3 over. Now, one of these inequality signs is wrong. What do I do next to figure out which one is wrong, Julia? What did I do on the last problem? Right from here, I was at this step. What did I do next? What did I draw? Ah, you draw your number line. And what do I put on this number line? Maddie.
-2 and -3.
What? Look what I did.
I did the same thing.
Now, what else do I need to put on this number line? On the numbers. Max. I wrote down Martin. Max. What do I put on the numbers?
Oh, circles.
Now, are they open or closed?
Open.
Open. Now,
And then you put the
what is the, right, where is the 0?
to the right of the 2.
Okay, you're kind of on fire.
Then what do I do with that 0, Carson?
You plug it in to the original.
Yes, the original. So I have 0 plus 4 is greater than 0 squared plus 6 times 0 plus 10. In the original problem?
It's 5. Oh, we're
In
doing
the original, yes.
Okay.
I was like, whoa.
So, simplifying everything down, what do we end up with on the left, Roman?
4.
Yes. And what do we end up with on the right? Jose?
10.
Yes. Now look at this. Is this true? Is 4 greater than 10, Ryder?
No.
No, it's not. So where do we not shade?
0.
Don't shade where 0 is. So we're not shading on the outsides. Where do we shade? On the insides. Now I need to show you the other type of notation that they're going to ask from you. They're also going to ask for interval notation. This is with the parentheses and the brackets that we do with domain and range.
Wait, hold up.
Okay, slow down.
I have a question.
Yes,
I'm a
Naya.
little bit lost. Okay, 4 isn't greater than 10.
Right.
So we did,
You don't shade where 0 is then. 0 did not work.
okay. But if that was true, or if that was
If it was true,
We
then
would
you would
shade.
shade on the outsides.
Okay.
Okay. Now, interval notation is with the parentheses and the brackets, and it's where you read the number line from left to right. So what is our starting value?
Negative.
-3. Can I touch -3?
Yes.
Is it an
No.
open or closed dot?
You can't because it's open.
It's an open dot. You can't touch -3, so I put a parenthesis. What value is my max value? Reading left to right, what's my max value on the number line that I stop at?
-3.
-2. And am I touching -2?
No.
So you put a parenthesis.
No.
Look at you go.
Now, don't write this down because it could confuse your notes. I want to discuss how to write interval notation if we had shaded on the outsides. Still parentheses and brackets, but what is our starting value now? Reading left to right, what do I start with?
-2.
0.
-3.
I shaded. Look at the shade. Where does the shade stop on the left?
Positive. Negative.
Infinity.
In negative infinity. It keeps going down. So our starting value is negative infinity. And then reading left to right, where's my first stop? When did I stop shading?
At 3.
-3. Was I touching -3?
No.
Parenthesis.
Wait a minute.
Then there's a pause where I didn't shade right. So you put union, the symbol, a U. It just is the symbol for or. Where do I start shading again?
-2.
To infinity. And done.
What is that? Is that supposed to be U or V?
It's a U for union. You learned about it in geometry a bit. In probability.
Not gonna lie, I do not remember anything from geometry.
I don't.
So well,
I wasn't the
best teacher.
Now, would you like for me to do another example?
Yes.
I figured. Let me do, I'm not going to make you do 5 or 6. Cross them out. You decide. Which one would you like me to do 1 through 4? You're doing the other 3.
Ooh, 3.
3.
3?
Yes.
Okay, easy peasy. This is actually, in my head, the easiest one on this paper. But I'm sure that you're like, I don't know. What, does anyone have any idea? Yeah, what can you do? You just, what's the opposite of squaring? Square root. You can square root both sides. And the square root cancel. Now, what is the square root of 64, though?
8.
Not just positive 8. Plus or minus 8. That's what makes this one tricky. Remembering that. So that's where our 2 numbers come from, our 2 bounds, they're called. One is where it's a positive 8, and one is where it's a negative 8. So I need to get x by itself. I add 5 over on both. This is 13. I add 5 over. And this is -3.
Wait a minute.
Oh. Why is there a plus and a minus?
When you square root something, you're asking what number times itself is the number inside the square root, right?
Yeah.
Not only do 8 times 8 equals 64, but also -8 times -8 is 64. So that's why it's both plus and minus 8. Now, we know one of these inequality signs is wrong. How do we start figuring out which one's right? First, we draw the what, though? Draw your number line. And we have -3 and 13. And what do I put on these numbers?
Closed circle.
Closed, that's good. And I have to figure out where 0 is. Where is it?
In the middle. Somewhere.
Yes, in the middle. So now I'm going to check. I'm going to plug in what? 0. So 0 minus 5 gives us what?
-5.
What is -5 squared?
25.
So what do we ask about this?
64 less than or equal to 25.
Is it true? Is 64 less than or equal to 25? No. So what do we not do?
Shade on 0.
Don't shade where 0 is. So where's 0?
In the middle.
In the middle. So where do I shade? On the outsides. Which notation would you like to see from me? Which one are you more unsteady on? Do you want me to show you both?
Yes.
Okay. So we'll first do inequality. We have how many regions shaded? How many regions are shaded here?
2.
So we're going to need 2 inequalities. One for the left side and one for the right.
Do we have to write another U?
I'm going to, no, not an inequality notation. So x is where on the left? X is
To the left. To the right.
less than or greater than?
Less than.
Less than? Which number?
-3.
-3. X is less than or equal to -3, or x is what? Greater than or equal to 13. Now let's show it in interval. What's the lowest possible value shaded?
-3.
Follow the shade. It keeps on going down to what?
Oh, -3.
Negative infinity. Then read left to right. What's the first value I hit? -3. I stop at -3. Am I touching -3?
Yes.
Yes. So what do I put? A bracket. Union with, where do I start shading again?
13.
Am I touching 13?
Yes.
Yes, it's a closed dot, right? So I put a bracket. And when do I stop shading?
At infinity.
At infinity.
Are we? Wait.
Any questions here? Yes.
So how is it touching the -3 and 13? They're not touching the -3 and 2 in the other column.
So, load. On this one, we had open dots. We didn't have an equal to sign underneath the inequality, right? It was just a greater than symbol. So we had open dots. Here, we have closed dots because it was less than or equal to. So we created closed dots. So we are touching negative 3 and 13. Any other questions? I do want to show you if on inequality, if instead we had shaded between here, what would the inequality of this look like? X is where compared to the two numbers? Outside or between? Now it's between. So literally, you write X between the two numbers with our inequality symbols between, and we're done. Oh, not equal to, I'm so sorry. These are open dots. So X is greater than 1, and X is less than 3. That's what this would look like if we shaded between.